Hi guys, this is Karthik Arora. So I'll be discussing edit distance in this video, and it's a very classic DP problem. I'll try to explain it in the best possible way by explaining the recurrences and writing a bottom-up code, hopefully a bottom-up code for the problem. Okay. Also guys, if you haven't subscribed yet, please do subscribe and like the video. Also, if you like the explanation, let me know in the comments. So we are given with these two strings S1 and S2. We are allowed to do some editing operations on string S1, and once you have done some editing, you would like to find the minimum number of editing operations that you have to do on string 1 so that string 1 gets transformed into string 2. So let's take the example given here. We have the two strings love and movie. Now the editing operations are three types of editing operations. Replace, you can choose any character of string 1 and replace it with any other character, right? So I can choose this O and convert it to Z. That's as per my wish. This is an editing operation. Another one is remove, and the last one is delete. Oh, sorry. Let me check. I'm forgetting one of the operations. Add one. Okay, so insert or add. So I can insert any character, I could remove a character, I could replace. So I could choose this guy, I could remove it, so my string will be OVE instead of love. I could delete it. Okay, and the another thing is I could add something, so I could add a D here and it will be loved. So the thing is that these are the types of editing operations I can perform. Let's try to evaluate the answer for love and movie. So initially at L, I could perform three operations, either replace, remove or add. Suppose that I perform the operation replace, then obviously I'm going to replace L with M because that maximizes my chance of getting the minimum number of editing operations. So if I'm performing the operation replace, then obviously I'm going to replace L with M, and these two strings have already matched here. Now you have OVE and OVIE. Alright, so the idea is that you could, given the string, you could perform any replace, remove, add operations, and whatever is the minimum possible operations that you can perform, that you have to print. For this particular string, the answer is 2. You can try it out on your own, or I'll just tell you how. So the answer for these two particular strings is 2 because I can replace L with M and I will have move and movie. Now I can simply add and insert a character I at this position and I'm done. So two editing operations and therefore output is 2. So let me get to the explanation now. I would recommend you to pause the video, think of a brute force solution, and then you will see how I optimize it further. Okay, so I have this string S1 and S2, capital S1 and capital S2. So S1 consists of the characters small s1, s2, s3. Let me just call these strings S and P. It will be a better, more understandable notation. So my string S is S1, S2, S3, so until Sn, and my string P equals to P1, P2, P3, and so on till Pm. Now if S1 and P1 are equal, then that is something good for me, because then I just need to think about these two substrings or these two suffix substrings, right, from S2 to Sn and P2 to Pm. If S1 and P1 were already equal, then my work was easier, that instead of the entire strings I just need to think about these substrings or suffixes from S2 to Sn and P2 to Pm, and I would like to find what is the minimum editing I need to do to make S2 to Sn equal to P2 to Pm. This was the case if S1 was equal to P1, but in the other case, when S1 is not equal to P1, I would have to make the first character of these two strings equal somehow. So either I can insert a character here in S1 and make it P1, okay, P1, S1, S2, so until Pn. So if I do an insert operation, insert edit, then my string becomes P1, S1, S2, so until Sn and the other string is p1, p2, p3, so on till pm. And now since p1 and p1 match with each other, I am left with finding what is the minimum edit distance between s1 to sn and p2 to pm. So this is cool, I can insert, and this is one edit operation. Other possibility is that I replace. So I can replace s1 by p1. I can choose to replace s1, and obviously I will choose to replace it with p1, otherwise it's of no use, it's a wasted operation. So from s1 I can convert s1 to p1, and then p1 and p1 match, and now I again need to think what is the minimum edit distance for the substrings s2, s3, so on till sn, and p2, p3, so on till pm. The third possible operation for me is that I could do insert, replace, and remove. So I could choose to delete s1 in a hope that this might minimize my operations. So if I delete s1, then I need to find, then I'm left with these strings s2, s3, so on till sn, and p1, p2, and I would like to find the minimum edit distance for this thing. Okay. And among these possibilities, whichever is the possibility most appealing to me, that means whichever gives me the minimum number of edits, I'm going to move towards that possibility. All right. So guys, this is the intuition here. You could definitely come up with a brute force now, because at every step you could try everything, insert, replace, remove, keep doing that, and whichever of the ways give you the minimum operations, that is your answer. Now I'll be defining a DP state for this particular problem, and I recommend you to try that on your own also. So I'll define dpij. This is going to be my minimum number of editing, or the edit distance. This is going to be my edit distance for the strings si to sn and the substring pj to pm, the second string. Okay. This is my dpij state. According to this state, what will be my final answer? My final answer will be, since I wanted to find out the edit distance of s1 to sn and p1 to pm, my entire strings, my answer is nothing but dp of 1, 1, because that would correspond to edit distance s1 to sn and p1 to pm. Now the only thing I'm left with is to build the recurrence. I would recommend you to try that on your own first. Okay, so I'm trying to evaluate what dp of ij is. I have these two characters si and pj. I need to make sure that these two match. The first characters of these two substrings must match. Only then will I be able to transform the string, right? And as we saw, we have three possible operations. So either I can do an insert operation. So one possibility is that I could insert pj here, and then pj and pj will match with each other, and I'll be left off to deal with the strings si to sn and pj plus 1 to pm. Okay, so and what one operation for inserting, and then I would like to find the minimum edit distance between the strings, between the substrings si to sn and pj plus 1 to pm, because pj already got matched. And what is the minimum, what is the edit distance for that? It is nothing but dp of I comma j plus 1, since the jth character matched. Other possibility is that I could perform the remove operation and remove si. And now I'll be left with the strings si plus 1 to sn and pj to pm, and I would like to find the edit distance between them. So that will be dp of I plus 1 to I plus 1 comma j, because si got deleted and I'm only left with the substring si plus 1 to sn. Third possibility is that I could perform an, okay, so this guy was insert, this guy was delete, replace. Okay, so I can perform a replace operation, and si will become equal to pj, and si and pj will match each other. Then I'll be left with the remaining substrings. So 1 plus dp of I plus 1 comma j plus 1, because the ith and the jth characters matched each other of the substrings that I wanted to match. and I'm left with the remaining substrings. So among these three options, I'm going to choose whichever gives me the less number of edits. So I will choose the minimum among these three. So guys, that's it. I'll be implementing this thing in code now. Also, a base case could be a nice base case. Let's think about that also. All right, I'm just I'm just keeping these recurrences in mind, then it will be easier for me to code. Otherwise, I'll have to think all the cases once again. Yeah, so we can think about base case. Let's say that I've reached the end of one string. My string was of length n, but I reached n plus 1. But I haven't reached the end of this string. Or let's say that I've reached the end of both these strings. So that will be n plus 1 comma m plus 1. That is going to be 0 because these two strings represent empty substrings. And how about I've reached end of only one string? Then the only operation that I can perform is basically keep either deleting from S1 or keep inserting into S1. Because if S1 is an empty string and I'm still left with some part of the string P, right? The Pj to Pm is still not over, then the only thing I can do is insert. Whereas if this guy is empty, then the only thing here I can do is delete all the remaining characters here. So that is also pretty clear. It will be either inserts or deletes and the length of the string that remains. So hopefully these two base cases are clear. I'll start with the implementation now. So I've just taken the input of the strings S1 and S2 and I'll be implementing the solve function now. This solve function is used to calculate the edit distance between the strings S1 and S2. So I'll just go for top down. It will be easier in top down. However, bottom up is also possible since we have the recurrences. Si and j represents the substring that I am still left to basically the substring that I want to match. S1 from I to last character and S2 from starting from j till the last character of S2. Initially I would want to match the entire strings from the 0th indices. And let's have an dp array to store my intermediate results. Let me give this 5001 and 5001. Initially I'll initialize my dp array to a value. That means that this particular state has not yet been calculated. So let me say dpij becomes -1, meaning that these states haven't been calculated yet. Now you are going to reach the solve function. You will check whether this is a base case or not. So if I equals to s1 dot length and, or let's just say either I equals to s1 dot length or j equals to s2 dot length. So if either of the strings has been exhausted, let's see what we can do. This will be a base case. I'll implement this thing in the end. Otherwise, I'm going to have three options: op1, add, op2, delete or remove, and third option, add, remove and replace. Okay, among these three options I'm going to select whichever is the best answer. So among these three, choose the minimum. Also, once I've selected the answer, I should store this particular state. Okay, that the answer for the substrings from si to sn and s1 of I till sn and s2 of j to s2 of m equals to this. That I will keep in mind. So if I already know this particular thing, when I try to solve this sub problem again, I should be able to return it instead of solving the same sub problem again and again. So if this thing has been calculated already, then return it simply, and that's good. Let's see what happens when I add a character. When I add a character, si to sn remains the same, so I remains there, j gets matched, and we're left with this substring. This is the same thing that I discussed in the recurrences part. So if I remove it, then this is the case, and if I replace it, then it's this. This is cool. Let's just implement the base case now. So if I equals to s1 dot length, so if s1 is exhausted, then I will need to do add operations, and that add operations will be equal to the number of characters that are still left in s2 to be matched. So that is going to be s2 dot length -1, right? Otherwise, the other thing is that if s2 has been exhausted, sorry, s2 dot length minus j, this will tell me the number of characters that still need to be matched. Otherwise, it's going to be the number of characters that I need to delete from s1, and that will be s1 dot length -1. I should return the one which is larger, because that will like one of these strings is the string that is costing me all the operations, and whichever it be, that will be taken as my answer. If I equals to this, then my answer is this. If j equals to this, then my answer is this one. Okay, so I am guessing this will work. Let me try out. dp cannot be used. Okay, this is not bottom-up code, my fault. Also be sure to pass your strings in by reference, okay? Otherwise this will definitely time out. Every time you pass a string, it will be copied again, and only the passing itself will be big O of n, and your solution becomes n cube because of that. Let me try this love movie. Okay, so there is some problem. String input dp to be honest, this seems all right. Let me just print these strings once. So I called the solve function using the indices and s1 and s2, and then I'm using this thing. If I equals to s1 dot length or j equals to this guy, this should not be the problem. This should also not be the problem, but it's always good to convert your integers into, like, unsigned integer to integers. If dp at ij is not -1, you return it, and I have initialized my dp array to -1, so it will be -1. Among these three options, op1, op2, op3, there should not be any problem as such. Okay, so this is a very dumb mistake from my side. I haven't written the return statement here. So I am never hitting the base case, I'm never coming out of recursion. And answer is incorrect. Also, one last thing that I forgot is that if the characters are already equal, I don't really need to do anything, isn't it? So if s1 of I is already equal to s2 of j, then you don't need to perform any operation. You can save yourself the effort. Okay, and let me say integer answer. If these two are already equal, then why perform any operation? You can simply have, okay, answer becomes equal to, you don't perform any operation, so you don't add a 1, but your characters matched, and now you only have the smaller substrings from I plus 1 and j plus 1. Okay, now this should work and we will hopefully get an AC. Yep. So guys, if you're finding this content helpful, make sure that you subscribe to my channel. Also, I would like if you guys could make a nice comment and let me know that this helped you. Thanks for watching guys. Bye bye.